For a linear equation of the form y equals mx plus b, the slope of the line is m, and the y-intercept of the line is 0, comma b. The equation is said to be in slope-intercept form. Example, graph y equals 2x minus 4. A is 3, 2 a solution. B is 4, 8 a solution. Let's remember, our slope-intercept form of the formula is y equals mx plus b format, where the slope we know is 4, and the y-intercept is the v-value, right? Which would typically give us a full answer, 0, comma, and then the v-value, whatever number there is on our equation. Okay, so in this case, our equation is y equals 2x minus 4. Well, we can always build a table. And do notice, you get to pick x values, right? So random x values such as 0, 1, and 2. And you're welcome to fill in the table and graph from the table. It still works. It'll be the same idea, except let's try a different way of graphing. So you're welcome to use the table though, okay? But for this case, let's look at the slope. Using the slope, we know the slope is 2, m equals 2. It's the number next to the x, the m value. And we can always put over 1 to make it easier to use for graphing. This way it's in the form of rise over run. We can also notice the y-intercept. The y-intercept is given just by looking at the formula, right? We know that the formula contains negative 4. So our y-intercept therefore is 0, comma, negative 4. Once again, note that negative 4. At the end, the one that has no variable is the one that is our y-intercept value, or the y-value of the y-intercept. The full answer for the y-intercept is 0, comma, negative 4 with the parentheses on the outside of it. Okay, so let's try sketching it or graphing it. So label our x and y axis in this case, and let's start by graphing the y-intercept. There's our y-intercept at y value of negative 4 on our y-axis. Okay, from there on, we're going to use the slope to continue our graph. Our slope tells us to go, because it's positive, tells us to go up 2 over 1. So we're going to go up 1, 2, and over 1 from the original location. In other words, our y-intercept. And now from our new location, we're going to go up 1, 2, and over 1 for our next location. And we're going to repeat this again, up 1, 2, and over 1, because that's our slope telling us how to graph. Up 1, 2, and over 1. And finally, we can draw a line. And once you feel like you have enough dots to make a straight line. Usually choose more than enough, but I recommend 3 dots. So now that we've graphed our equation, so there is a graph of our equation, we want to check the answers. Do be aware, you're welcome to check this via mathematics. In other words, plug in the x and y value to your equation and see if they're equal on both sides of the equal sign. For this case, we're checking by graphing. So checking by graphing, let's plot A is 3, 2 a solution. So plotting it, let's see, where is 3, 2? Hey, look at that. It's a red dot, lies right on top of another dot that we previously graphed on here. So that means it is a solution in this case because it's on the line. So 3, 2 is a solution. It is a solution. How about we try B then? B is 4, 8. Is 4, 8 a solution? Let's see, 4, 8. There is our dot. A, is it on our line? No, unfortunately, 4, 8 is not on our line. So that means it's not part of the graph or part of the linear sketch. So not a solution then. And technically, this tells us, and visually we can see whether it's an answer or not.